packet. If not, you need a copy of it because you want to have your notes. So when we do the open notes, you have your own notes. So I'm just going to show you how to do it, but then you're going to do it on your own today or tomorrow, and I can help you again on that part. So it says we can use the horizontal distance that a projectile travels to determine the x value of the vertex, right? Because it's symmetrical. So if I landed at about 40 centimeters, whatever the average is, where's my vertex? Must be 20, right? Because the vertex will be halfway along that path of the parabola. So it says in this diagram, let's pretend the projectile lands 50 centimeters away on the ground. What does that tell me the x value of its vertex must be? If it goes 50, where does the vertex happen? At 25, right? Halfway. Because of the symmetrical nature of this projectile. You with me so far? So that's the first calculation you're going to do on your own catapult. You're going to have the average distance and you're just going to cut that in half, right? Because the vertex would be halfway of your landing site. All right, now we need to do a little bit of physics. So this is actually getting into a little bit of the physics of gravity. Gravity pulls on an object and it pulls on all of us with the same amount of force. So gravity is always consistent no matter what's falling. So whether it's a heavy ball or a light feather, gravity's acting on it. Then there's wind resistance and other factors, but gravity is always constant. So we're going to use gravity. If we find the maximum height, right? We want to find the height of our projectile up here. The y value of the vertex. You have to find the average fall time. This is fall time, right? It's falling towards the ground. So it launches and then it's in free fall with gravity. We only care about the free fall part. So what if it takes 1 second to go up and come down? How long is it in free fall? Only for half a second, right? You're cutting your numbers in half. Half the distance and half the time. So that's not too hard. Now this says, let's pretend in the diagram above, the object was traveling for 2 seconds. How long was the free fall? 1 second, right? Easy enough so far. Take your distance, cut it in half. Take your time, cut it in half. Now we're going to use the physics equation. The physics equation, you don't have to understand, I'm giving you the equation. The distance to the height of the fall is 1/2 the force of gravity t squared. D is the vertical distance traveled. That's what we're looking for, the height of our parabola. G is the effect of gravity, and T is the time in the air. It says the effect of gravity is either 9.8 meters per second squared or 980 centimeters per second squared. So depending on what units you're using, you're either going to use 9.8 or 980. Which one should I use in my problem? What units am I using in my problem? Meters or centimeters? If my problem's in centimeters, I want to use the centimeter number. If my problem's in meters, I'm going to use the meter number. So I'm going to write distance is equal to 1/2. That's just coming from the equation. The force of gravity is 980, right? Because they're telling me I'm using G, and I'm either going to use 9.8 or 980. And then what's your time? We said it was 1 second. What's 1 squared? Well, still just 1. So really, what is 1/2 of 980? Can someone do that calculation for us? So it's telling us if it went 50 centimeters and it was in the air for a second, we know how high it actually went in the air because of gravity. Somehow it went 490 centimeters in the air. That's 5 meters. So that's probably unrealistic of what we're launching, right? 50 centimeters is not that far. 100 centimeters is a meter stick, right? 5 meters would be 5 meter sticks. So 490 centimeters, that's a big arch, right? So just this is hypothetical. So the vertex of my projectile is at 25, 490. The 25 was half of the distance, and the 490 I got using that equation with gravity. So you're going to have some data. I'll help you apply this to your data. It won't be that bad, believe me. How do I write the equation in vertex form? Do you remember vertex form? So we're going to take the vertex of a projectile and just rewrite it on the next page so that you don't have to flip back and forth. Did you need something else still? We took the 25 from the x value and we took the 490 from the y value and we wrote it as a coordinate. 25, 490, x and y. So I'm just moving it to this other page and we're going to write it in vertex form. This is like what we did, like all of unit 2 into unit 3. How do I show that I go right to 25? I'm going to leave this a here. X minus 25 goes to the right. What does the squared do? Just tells me it's a quadratic, right? What does the a do? That's going to be the steepness factor that I don't know yet. And the k value, I went up 490. It says, note, we still need to solve for the a value of the quadratic. What other points do we know lies on our parabola? We know where the parabola landed, right? Our parabola, I'm not going to started at 0, 0, went to the vertex, and ended on the ground at 50, 0. So we can use that 50, 0 to solve for a. To me, this is like you're really doing some algebra 2 now on your catapults. I know, like you built them in algebra 1, but you didn't really understand what vertex form was, the right and the up. And now we're using some algebra to solve for the a value. You'll have open notes. We're going to practice it on your own catapult. We're going to practice it tomorrow, and you'll be pros by Thursday. I'm plugging in x and y for 50 and 0 in this equation right here. So the y value is 0. The a value is what I'm trying to figure out. The x value is 50. And I'm just going to copy the rest of the equation that I have right above it. I'll give you a minute to just copy. All I did was I replaced x with 50 and y with 0 because I know that that lies on my parabola. Now I'm going to solve for that a value right there by moving everything to the other side of the equation. What could I do first by order of operations to simplify this problem? You could subtract the 490 to the other side. I just like to follow, let's do parentheses first, just for the sake of doing parentheses first. I'm going to rewrite it so I don't lose anyone. But would you agree that 50 minus 25 is still 25? Okay, what's the next step when I do order of operations on a problem? I should do the exponent. What's 25 squared? 25 times 25. Oh, it's not on that chart. Isn't it 625? Does anybody know? I'm pretty sure 25 squared is 625. I can't to prove it to. So 0 equals a times 25 plus 490. Now I'm going to do what someone over here said. Let's subtract the 490 to move it to the other side. Minus 490. This is just your algebra to solve it. Negative 490 equals a times 625. Anyone know the last step to get your a value by itself? What's the inverse operation? I want to do division. Division. To get that 625 to the other side. Does this come out as a terrible decimal? Negative 490 divided by 625 is how much? Oh, it's not that bad. Negative 0.784 equals a. How did I know a should have been negative? Why does it make sense that a is negative? I didn't know that a was going to be 0.7, but how did I know a was negative? It's concave down, right? If a was positive, what would my parabola look like? Concave up. So I hope you know that part. Then it says, let's write our final equation. Y equals the a value, negative, oops, I put the decimal in the wrong place, negative 0.784. We said it was x minus 25 490. So you just figured out the equation for that person's catapult so that we can plug it into our graphing calculator and figure out the landing site when we move it up on a platform. Moving it up on a platform is just going to change that launch height. So you just add to your 490 basically, move it up. Okay, so